Welcome to Module 4, Lesson 5, Data Representations. So these are the types of data representations that you'll be looking at on the SAT, and you should be familiar with these diagrams, right? You'll be looking at tables, bar graphs, line graphs, scatter plots, histograms, and pie charts. What's really important about working with data representation is that you know how to read each diagram and each graph, right? So you should be able to extract information from the diagrams by reading the labels and the titles and paying attention to trends, peaks, or outliers. You should be able to perform calculations using data representations by using the data to calculate percentages or averages and applying proportions when dealing with part-to-whole relationships. You should be able to analyze trends by looking at diagrams, by looking for patterns, whether they're increasing or decreasing, and identifying relationships between two variables. And you should also be able to interpret the context, right? You want to be able to relate the information in these diagrams to the real world context in the scenario. So let's take a look at an example. I have a dot plot here, and it shows the number of goals that Jessica scored in each lacrosse game last season. And how many games did she score 2 goals? So it's important that we know how to read a dot plot here, right? We have this diagram, but what does it represent? So if you look on the number line, the number of dots above each number represents the number of games that she scored that many goals. So for example, she scored 0 goals in 3 games, right? Because we have 3 games over the number 0. She scored 1 goal in 3 games, right? So how many games did she score 2 goals? So we'll go to the number 2 and count the number of dots. 1, 2, 3, 4. We have 4 dots over the number 2 on the number line. So that means in 4 games, she scored 2 goals. Now let's look at a line graph. The graph was created by an employee at a gas station. For how many gallons would it cost a customer $30? So when we're looking at line graphs, we're looking at the X and Y axis and what they represent. So the x-axis here represents the number of gallons. The y-axis represents the cost of gallons in dollars. So let's look at what the question gives us and what the question's asking us for. It's asking us for how many gallons, right? So it's asking us for an x value, that it would cost a customer $30. So they give us the y value. The y value is $30. So we'll go to the y-axis and we'll go to 30. Move over to the graph, right, to this point here, right? So what is the x value when y is 0? So if we go down, we see that the x value is 8. So that represents 8 gallons, right? So it would cost a customer $30 for 8 gallons. Please pause this video and work on the Lesson 5, Level 1 problems in the workbook. Moving on to Level 2. Here are some tips for working with data representations on the SAT. Take your time. Read all the titles carefully, the labels, the X and Y axis. Estimate when necessary, right? Especially for complex graphs. Sometimes you're just going to need to estimate. Look for units. Make sure that you understand the units on each axis or column. And answer the question, right? Focus on what the question is asking you for. I can't stress this enough. I can't tell you how many times I've had students do all of this work and they don't answer exactly what the question is asking them for. They could do all of the work correct, but then not answer the question properly. So just make sure that you read the question carefully and you answer what the question is asking for. Let's take a look at analyzing some graphs. The graph here models Craig's trip to visit his friend in another state. In the course of his travels, he encountered both highway and city driving. Explain what might have happened in the interval between B and C. So if we look at the graph here, between B and C, right, the graph is constant. So our x-axis represents the number of hours, and our y-axis represents the miles traveled. So what's happening between B and C? Well, between B and C, time is passing, right? The hours are increasing, time is moving on, but the miles traveled are staying the same, right? He's staying at 110 miles, right? He's not increasing his mileage. So that means he's staying in one place. Time is moving on, but he's staying in one place. So what might have happened? Right? Craig might have stayed at a rest stop between B and C. Right? There are various ways you can answer this question as long as it makes sense that he's staying in one place between point B and point C, right? He's not traveling any further in that interval. Determine Craig's average speed to the nearest tenth of a mile per hour for his entire trip. So if we want to calculate his average speed, right, we're going to have to use basically the slope formula, right, from his starting point to his ending point. So we're going to go from point A to point E. So what's our point in point A? That's 0, 0. That's where he started, right? At 0 hours and 0 miles. And he ended at point E, which is the point 7, right? 7 hours, 230. Okay, so what we're going to do is we're going to substitute those values into the slope formula. And we'll get 230 minus 0, right? That's our y2 minus y1 over 7 minus 0. That's our x2 minus x1. And that's approximately 32.9. So Craig's average speed was 32.9 miles per hour. Please pause this video and work on the Lesson 5, Level 2 problems in the workbook. And Level 3 will analyze and interpret some more complex graphs. So the accompanying graph shows the amount of water left in Rover's water dish over a period of time. How long did Rover wait from the end of his first drink to the start of his second drink? Okay, so let's take a look at the graph first. Our x-axis represents the time in seconds, and our y-axis represents the amount of water that's in the dish. So let's start reading the graph from left to right. So at the start, Rover has 400 milliliters of water in his dish. And if you notice, if we start moving to the right, between 0 and 15 seconds, the graph was constant. So this means the amount of water in his dish is staying the same between 0 and 15 seconds. So between 0 and 15 seconds, Rover isn't drinking anything. But then at 15 seconds, the graph starts to decrease, which means the amount of water in his dish is decreasing, which means between 15 and 30 seconds, Rover is drinking the water, right? So 15 to 30 seconds, that's his first drink. And his first drink ends at 30 seconds, right? Because if we keep moving to the right, between 30 and 60 seconds, now the amount of water in the dish is staying the same again. So Rover isn't drinking during this time. And then at 60 seconds, the graph starts to decrease again, which means now Rover is drinking again. So when did he start his second drink? When did the graph start decreasing again from the second time? Well, that started at 60 seconds. They want to know how long did Rover wait from the end of his first drink, right, which was at 30 seconds, to the start of his second drink, which was 60 seconds. So how long did he wait? How long was this interval right here? And from 30 to 60 seconds is 30 seconds. So Rover waited 30 seconds from the end of his first drink to the start of his second drink. Please pause this video and work on the Lesson 5, Level 3 problems in the workbook. Once you're finished with the problems in the workbook, you can move on to the next video for Lesson 6.